We've all been there, right? You're setting up a screen, maybe in a lobby or a big conference room, and the HDMI cable just isn't going to cut it.
Oh, absolutely. You hit that, 25, 30-foot limit, and the signal just dies.
And even if you get a super long, expensive cable, trying to pull that big connector through a wall or conduit is just a nightmare.
It's a real pain.
So today we're doing a deep dive into the solution. It's this move where traditional AV gear is sort of merging with standard IT networking.
Mm-hmm.
And we're looking at one device in particular, the NTI ST-IPHD-LCUNV. It's a bit of a mouthful.
It is, yeah. Low-cost HDMI over gigabit IP.
What does that actually mean for us?
It means we're fundamentally changing the game.
Okay.
We're not just stretching a video cable anymore. We're literally turning your video signal into network data.
So it completely ditches the HDMI cable for the long haul.
Exactly. It runs on the Cat5 or Cat6 Ethernet cable that's probably already in the walls of the building.
Which is everywhere.
It's the appeal. You plug your video source into the transmitter box, your screen into the receiver box, and they just find each other on the network.
And the specs on this are pretty impressive. It says you can get 1080p video up to 330 feet away.
That's 100 meters on a single cable run.
Okay, but let's get into the weeds here. You're taking a huge uncompressed video signal and shoving it through a network port. I mean, what does that do to the picture quality? Are we talking about a blocky mess?
That's the key question. And no, not blocky. The word they actually use is fuzzy.
A fuzzy.
Yeah. To manage the bandwidth, it uses something called MJPEG compression.
Okay, what's that?
Well, you know how Netflix or YouTube, they look at the differences between frames to save space? MJPEG doesn't do that. It compresses every single frame individually like it's its own separate picture.
So it's basically treating the video like a super fast photo slideshow.
That's a great way to put it. The big advantage there is speed. There's almost no processing delay, so your latency is incredibly low. We're talking like 33 milliseconds.
That's basically instant. You'd never notice that.
You wouldn't. But the trade-off is efficiency. It uses a lot of bandwidth, which is why it needs a gigabit network.
And the fuzziness.
That comes from the compression. For moving video, like a promo reel or a movie, it looks perfectly fine, smooth. But if you try to display, say, a spreadsheet with tiny text,
Okay. The fine print might get a little hard to read.
it'll be a strain on your eyes, for sure. It's built for digital signage, not for mirroring a computer desktop where you're reading emails.
Got it. Now, you mentioned it runs on the network. The setup guide says it's plug and play, that they automatically find each other. How does that work without an IT admin punching in IP addresses?
Yeah, they just use a simple broadcast.
Hmm.
As long as the transmitter and the receiver are on the same local network, the same subnet, they'll handshake.
But it has to be a local network, right?
Yes, and that is a big but. This is for a LAN only. You can't, route this over the internet to your office across town. It's not designed for that.
That makes sense. But the really cool thing about using IP is you're not just stuck with one-to-one.
Right.
You could take one source and send it to, 20 screens at once using a network switch?
You absolutely can. But this is exactly where people get into trouble.
How so?
If you just take a cheap, unmanaged switch you bought at a big box store and plug in multiple transmitters, you're probably going to bring your entire network to its knees.
Because of all that bandwidth we talked about.
Exactly. A dumb switch doesn't know what to do with that video stream, so it just floods it.
Yeah.
It sends a copy of that massive stream to every single port on the switch, whether there's a screen there or not.
So it chokes out all the regular internet traffic.
Completely. You need a switch that's smarter. You need a managed switch.
One that supports things like VLANs and IGMP. That's one of those acronyms that sounds complicated.
It sounds scarier than it is. Just think of IGMP snooping as like a subscription service for your network ports. It makes sure the switch only sends the video stream to the ports that have actually subscribed or asked for it.
Ah, okay. So it keeps the video traffic contained, leaving the rest of the network alone.
Precisely. And once you have those managed switches, you can do some really cool things.
Like cascading them, right? The guide mentions you can extend the range even further.
You can daisy chain up to 3 levels of switches. By doing that, you can get a screen that's almost 1,000 feet away from the source.
1,000 feet. Wow. That covers a huge space, like a warehouse or an entire school floor, without needing to run crazy expensive fiber optic cable.
And all for what? About $180 per unit? It's really democratizing this kind of large-scale setup. You don't need a specialized AV tech anymore. You just need a good network admin.
That's really the big takeaway here, isn't it? The world of audiovisual tech isn't its own separate thing anymore. It's just another service running over the IT network.
Video signal is just another data packet. It's no different from an email or a file you're sending to the printer.
Which leaves us with a final thought to chew on then. As this technology becomes the absolute standard, does the cable guy who runs AV eventually just become another IT person?
The tools are definitely changing. It's less wire strippers and more logging into a web interface.
Something to think about. Thanks for breaking all this down for us.
My pleasure.